Sometimes with trigonometric functions, we need to find the angle measure based on, like our triangle and whatnot. So what we're going to use is the inverse of our trig functions. So we're going to be looking at those different inverse trig functions. We're going to be specifically looking at sine, cosine, and tangent. To start off with, we're going to look at the graphs first and then come back and write down some information about those graphs. So if I'm looking at my sine graph, the purple there is the true sine graph. The inverse sine is going to be that red graph. Remember that an inverse function is reflected over y equals x, which would be approximately this line I'm drawing here, dashed line here. So if I'm reflecting that over, what ends up happening is we only have a limited amount with that red there for the inverse sine. And the reason why is because if we were to truly reflect all of that sine function, we wouldn't have an inverse function, because this graph here would just keep going like this back and forth. Well, based on the definition of a function, this doesn't pass right now, currently, the vertical line test. So since it doesn't pass the vertical line test, we limit where our inverse sine function actually exists. Same thing actually occurs with our cosine graph there. You guys can see there that the reflection does take place for a little bit and then it cuts off just like the sine function did. The tangent function, however, if I'm looking at this, it truly is just a reflection of this curve. It isn't a reflection of any of these. And that's okay, because it covers that whole area based on that reflection of just that one piece. So let's talk about, what is the domain and range for all of these different functions, since obviously you guys could see the sine function and cosine function had a little bit of a limitation. So if we have the sine of -1 of x, which is our arc, sometimes you'll see it as arc sine or inverse sine, so just something to look at. The domain for this is from -1 to 1, and our range is from -π/2 to +π/2. Notice these are both brackets, which means that those points are included. Looking at the arc cosine or cosine to the power of -1, this domain is from -1 to 1, and the range here is from 0 to pi. Again, brackets, so we know it's denoted that it is included. The tangent function, its domain is from -infinity to +infinity. So because we're dealing with infinity, we'll have parentheses. And its range is from parentheses, so it's not included, -π/2 to +π/2. So, and that, like I said, is based on the graphs that we just saw, but this is a little bit more specific. Here's what is actually going on and whether to include it or not include it. Sometimes you'll be asked to evaluate a inverse sine function or inverse tangent function, whatever, without using a graphing, without using a graph, or without actually using a graphing or calculator of any sort. Generally, when this happens, it is with the unit circle. Okay, so what's actually going to happen here is if I were to say, what is the inverse sine of 1/2? And that equals x. So what I'm doing here is I'm trying to figure out, and remember, our points are x, y, and that's really cosine, comma sine. So what I'm doing here is I'm looking for where does the sine value, aka the y value, equal a half? Well, it equals a half here and here. So since it equals a half in those locations, I'm going to be using that angle measure. Okay, so whenever you're looking for an inverse, you're looking for an angle measure. So in this situation, my x value, I'm going to have two of them, is going to be at 5 pi over 6 as well as pi over 6 because I was looking for where does sine equal a half using my unit circle. So I could do the same thing with a cosine of -1. You know, if it's negative square root 2 over 2 equals x. So again, cosine is the x value, so I'm going to be looking for that negative square root 2 over 2, in which I located it there, so I just need to state at what angle measures. So 3 pi over 4, as well as at 5 pi over 4. So that's using the unit circle. If they're asking you, or if you're being told that you can use a calculator, let's look at a situation like that. So let's say the right triangle trig here. This picture might not represent what it actually looks like, as I'm just throwing numbers on here, just so you're aware. So let's say that I've got this situation here. So when I'm looking at this, I'm looking for my angle measure, and I'm going to use SOHCAHTOA. When I'm using my SOHCAHTOA, remember the first question you always ask yourself is, do I have a hypotenuse that's labeled? Currently, we do not have a hypotenuse labeled because that would be here and nothing is there. So, by default, cosine and sine are gone. So we have tangent of theta equals 4 over 9. Since we're looking for that angle measure, we're going to use tangent -1 4 over 9 to equal theta. On your calculator, make sure you're in the mode that you want. I'm going to be in degree mode for this. Generally, what you do is hit second tangent, and it'll pop up with that -1. And it should give you your measure. So in this case, it'll be approximately 23.96 degrees. So that's using a calculator, and that's okay to use an approximation. But so there's different ways that you could calculate your inverse sine. You could look at the graph, find where it intersects if need be. You could use the unit circle, or you could use the good old calculator.